Hello students, I am Dr. Preeti and I am back with another video for the revision of class 10 science syllabus. In the previous video, we have revised the chapter heredity and now today we are going to start with light chapter. In light chapter, we are going to look about the topic concave mirrors. Concave mirrors. In this topic, we are going to revise the uses as well as the ray diagrams of concave mirrors. For 2 marks, surely you will be having a question based on drawing the ray diagrams. It could be either from mirrors or lenses. Both these are very important. So today we are going to have a look at concave mirrors, all the ray diagrams. Okay. So I would advise you all to just sit with your pencil, compass and your scale and draw the ray diagrams along with me. Don't just have a look at the ray diagrams. Just practice it. Pause the video and try to draw the ray diagrams by yourself. Okay. So just let's practice. For drawing the ray diagrams, we just need to know the rules. There are 4 rules for drawing the ray diagrams, out of which even if you remember just 2 rules, then also you will be able to draw all the ray diagrams correctly. Drawing these ray diagrams is so simple that if you draw it along with me, I promise you that you will be able to draw it correctly even without practicing it any further. Okay, so just pay attention. This is a concave mirror. In a concave mirror, the reflecting surface is curved inwards. This point, that is a midpoint of this mirror, is known as pole. When parallel light falls on a concave mirror, then after reflecting from it passes through the focus. So the point from which all the parallel lines are going to pass, that is focus. If you imagine that this is a circular thing, its mirror is taken from a spherical structure, then that sphere should be having a center. And that center is known as center of curvature. Okay. So, the first rule says that if a ray of light is coming parallel to the principal axis, then after getting reflected from the mirror, it will pass through the focus. This is the first rule to draw the ray diagrams. Okay, I hope that's very simple. Now, the second rule says that it's just the opposite of the first rule. Whenever you are drawing any ray diagram, don't forget to show the polished surface by showing these lines. So, the second rule is just the opposite of the first rule. It says that if any ray of light is passing through the focus, then after reflection from the mirror, it will go parallel to the principal axis. It will pass parallel to the principal axis. Okay. Now, the third rule, it's very important. We are going to use basically the first and the third rule to draw all the ray diagrams. Third rule says that if any ray of light is passing through center of curvature, then it will, after reflection, it will retrace its path. After getting reflected from the mirror, it will follow the same pathway only. Okay, so that will be the ray. Okay, now one more thing is there. Whenever you are drawing any ray diagram, remember that whatever is the distance of the pole from the focus, the same distance should be there between focus and center of curvature. Suppose you are taking the distance between pole and focus as 3 centimeter. Take this distance also 3 centimeter only. Okay, then you will land up with correct ray diagrams only. I promise you that. Now, the next rule. This rule is true for any mirror, whether it's a concave, convex or a plane mirror. That is a part of one of the laws of reflection only. That you know that angle of incidence is equal to angle of reflection. So it is from that only. This is the angle of incidence, the angle between the incident ray and the normal. So the principal axis also behaves like a normal. The angle between the incident ray, the angle of incidence is equal to angle of reflection. Okay, so these are the 4 rules which we can use to draw the ray diagrams. Okay, now one by one we are going to draw all the ray diagrams. So for starting the drawing of the ray diagrams, we will place the object at different positions starting from infinity, and slowly and gradually we will be moving our object closer to the mirror. So we'll start and we will first place it at infinity. So what's infinity? When the object is very far away, very far away, that is called infinity. One of the conditions similar to that is the position of sun. Sun is very far away from earth, very far away from any mirror placed on earth, so that behaves like a infinity. So the light rays that are coming from sun, that will be parallel. I will show that the light rays coming parallel to the principal axis. Whenever we have to show that the object is at infinity, we can show parallel beam of light. Okay. Now, after reflection, since they are coming parallel to the principal axis, after reflection, where should they pass from? Definitely the focus. So they will pass through the focus. Both are parallel, so both the rays are going to pass through the focus. The point of intersection of the reflected rays is only known as the point where the image is formed. Okay. So with every ray diagram, now there is a twist that with every ray diagram, you should always write the position of the object, nature of the object, size of the object, size of the image, and the nature of the image. Okay, all these things have to be written with every ray diagram. In your exams, most probably you will be given just to draw the ray diagram. They don't ask you separately for writing the details, but it's always good to write the details as well. Okay, so what is the position of object? That was already mentioned in our question, that it's at infinity. So position of object is at infinity. What is the position of image? The image is formed where? At focus. The image is formed at the focus. Now, what is the nature of image? The nature of image is that it is real and inverted. Real and inverted. Why I am saying that it's a real image? Because the light rays are actually intersecting each other. Whenever the light rays are actually intersecting each other, that is a real image. And always remember that a real image is always inverted. Real and inverted always comes together only. And what is the size of the image? So you can see it's a very small size image. You can say highly diminished, or you can say it's a point sized image. Point sized image or a highly diminished image is formed. So that's all for the first condition, when the object is placed at infinity. Can you think of such an example? This position of the object and the image are used in a solar furnace. Concave mirrors are used for making the solar furnaces. So what happens in a solar furnace? The light rays from the sun comes and they just coincide at one particular point, and that where we keep the object to be heated. So if you want to warm up the water, if you want to heat up the water, we can place the water at the focus of that concave mirror. All the sun rays will be getting converged at that point, and so the water will get heated up. Okay, so this is the application of this particular condition. Okay, now we will be bringing our object closer. Now we will be placing it beyond center of curvature. When the object is placed somewhere between center of curvature and infinity, that is known as beyond center of curvature. Okay, so one of the light rays that is coming parallel, suppose this is a candle, so one of the light rays will be coming from starting from the candle only. Okay, that is how you have to show. For parallel lines, you need not show the object, but for every other condition, we will be showing the object. So the light rays are coming parallel to the principal axis. Now, after reflection, they will pass through the focus. Another ray of light that is passing through center of curvature will retrace its path and go back in the same direction. Where the two reflected rays will be meeting each other, that is the point where the image will be formed. So this is the place where the image will be formed. Image is formed between center of curvature and focus. Okay. For this condition also, you need to write all the four things. Position of the object is beyond center of curvature. Position of the image is between focus and center of curvature. Nature of the image. Really, the rays are getting intersected with each other. So it is also a real and inverted image. And size of the image, you can easily compare when you're drawing it in your copy. So you can just compare that the size of the image is smaller than the object. I hope if you are drawing along with me, then you must have got your image also at the same point. You can get the same position of the image even if you use some other rules. If you don't want to use the first and the third rule, you can use first and second rule. Totally your choice. You will be getting the same position of the image in that condition also. Okay. Now, the third condition, we will be bringing the object even closer. So, where we should bring our object? Now, we should place our object at center of curvature. Earlier, we have placed it beyond center of curvature. Now, we will be placing our object at center of curvature and applying the same two rules. Now, here is a trick. Either you can draw the ray diagram normally as we used to draw, or we can use a trick only in this condition. I'll tell you why. Actually, when the object is placed at center of curvature, image is also formed at the center of curvature only and exactly of the same size. So why I'm asking you to use a trick? थोड़ी सी cheating कर लेते हैं. Why? Because even if we get the position of the image slightly to the right or slightly to the left of the object, then our ray diagram will be considered incorrect in this particular condition. The image should be formed exactly at the center of curvature only. So what we will do, if we have taken the object 2 centimeter long, then at the same position we will draw the image also 2 centimeter long only. Right now we will not be placing any focus. Okay, what we will do, we will draw a parallel line here, a parallel line here, and we will join the two ends. The tip of the image with this line, we will join it. It will be probably passing through a focus, or we will, after it passes the principal axis, we will mark that point as the focus. And another ray of light that is passing through the focus. Okay, my line was slightly, yeah. So what rules we have used? One of the ray that was passing parallel to the principal axis, after reflection passes through the focus, and another ray of light that was passing through the focus, after reflection passes straight parallel to the principal axis. We have used the first and the second rule. Okay. In this condition, we can't use the third rule because light ray couldn't be shown passing through the center of curvature. That's not possible. Okay. So we will be showing using the first and the second rule to draw this particular ray diagram. Okay. Similarly, we have to write the details. Position of the object is at infinity. Position of image is also at infinity. Position of the object is at center of curvature. Position of the image is also at center of curvature. What is the nature of the image and the size of the image? The image is real and inverted. Really, the rays are intersecting each other, so it's a real and inverted image, and it's having the same size as that of the object. Okay, so for this condition also we have got the image. Now we'll bring the object even closer to our mirror. So where shall we place it? With every ray diagram, things that you should remember is always show the non-reflecting surface by drawing these lines. Always take the same distance between pole and focus as that between center of curvature and focus. Okay, this should be same. Then no problem with drawing any ray diagram. Now next condition is we will place the object between center of curvature and focus. Okay. One of the ray of light that is coming parallel to the principal axis after reflection will pass through the focus, and another ray of light that is passing through center of curvature striking the mirror, reflecting back in the same direction only. So where the image will be formed beyond center of curvature. And what sort of image it is? Real, inverted and enlarged. You can see the size of the object and the size of the image. You can compare that. So image is much bigger as compared to the object. Okay. When drawing this ray diagram, just remember one thing, that leave enough space for the image to be formed beyond center of curvature. Okay, sometimes it happens that the students just draw the ray diagram very close to the margin of the paper and they are not left with enough space to show the rays actually meeting each other. Hana? So remember that whenever the object is placed between focus and center of curvature, image is formed beyond center of curvature. So just leave some space for that. One more thing, do you remember something? Can you correlate something? When the object was beyond center of curvature, the image was formed between focus and center of curvature. And now when the object is between focus and center of curvature, image is formed exactly opposite to that, that is beyond center of curvature. Okay, so these two conditions are just the reverse of each other. Now we will place the object even closer. I hope you all are drawing the ray diagrams. Just pause the video and draw it by yourself. Then only it will be really fruitful for you all to watch this video. This is the pole, focus, center of curvature. Now we will be placing our object at focus. Use the same two rules and draw the ray diagram by yourself. One of the ray of light coming parallel to the principal axis after reflection passes through the focus. Another ray of light passing through center of curvature will retrace its path. Never forget to show the arrows. Okay, will retrace its path. So you can see that are your light rays meeting somewhere or they are coming to be parallel to each other. If you have taken proper distances between the two things, then the rays should be parallel to each other. And parallel rays never intersect. So these light rays are not going to intersect each other. So when the object is at focus, the light rays will be going to a great distance and we call it at that image is formed at infinity. Just the reverse of first condition, right? In the first condition, we have seen that when the sun was at infinity, image was formed at focus. And now when we have placed the object at focus, the image is formed at infinity. What is the nature of the image? Real, inverted and highly enlarged. Why we call it as highly enlarged? Because these light rays are going to a great distance. Okay. Is there any practical application of this condition? Yes. Actually, it is there and it's given in your NCERT book as one of the uses of concave mirrors. It is used in the headlight of cars. So, how it is there? That if this is the headlight of your car, a bulb is placed at the focus. Light rays coming from this bulb will get reflected from the concave mirror just placed behind the bulb and they will get reflected back and they will be going to a great distance. That is why the light from the car, headlight of the car goes to a great distance. Same is used in torches also. Okay, so this is the one of the use of concave mirrors, a practical application of concave mirrors. Now we will be placing our object even closer. That is, now we will be placing the object between pole and focus. This is our focus, this is our pole. We are placing the object even closer between pole and focus. One of the light ray coming parallel after reflection passes through the focus. Another ray of light passing through center of curvature will retrace its path, and these two light rays are appearing to be diverging from each other. So on this side of the mirror, when they are getting away from each other, getting even apart from each other, they are not going to meet here. So where possibly they can meet each other? On the same side of the mirror. In the opposite direction, if we extend the light rays in the backward direction, then we'll find that at a point they are going to meet each other. And this is the position where the image will be formed. The image will be formed behind the mirror. We call it as behind the mirror. But behind the mirror, how it will appear to us? That is called a virtual and erect image. And whenever we see ourselves in any mirror, if we are able to see our face in a mirror, that is always a virtual and erect image. Even in the morning when you are using a plain mirror to comb your hair, the image formed in a plain mirror is also virtual and erect. Okay, but in this condition the size of the image is bigger than the size of object. So when the object is placed very close to the mirror between focus and pole, then the image will be enlarged. The image will be virtual, erect, and position of the image is same side. We call it as behind the mirror. The image is formed behind the mirror. Is there any practical application of this? Yeah. Here comes the second use of concave mirrors. In your book, it's mentioned that concave mirrors are used by dentists. It is also known as a dentist mirror. So what a dentist do? They just use a concave mirror to visualize your teeth. So they put it into your mouth and they can obtain an enlarged image of the tooth and easily see what if you're having some dental caries or something that could be visualized by a dentist. Okay. So this is the last condition where we have to draw the ray diagram for the concave mirrors. That's all with the ray diagrams of concave mirrors. We have seen the uses of the concave mirrors also along with that only. Okay, I hope you were able to draw the ray diagrams. So keep studying, keep scoring.